I don't know. It's just a message saying like I need to ask, but I don't know how. Like, yeah.
I don't know
So
if there's international law for it, but we're all from basically different countries. So.
now it's getting more serious here as well. So I suppose that this is something good. But yeah, definitely. So okay, well, welcome everybody here to the OpenEEW Town Hall, second round. I just sent a message into the general Slack channel, so let's see if somebody else is joined. Of course, Andy will be here anytime soon, as soon as he's done with the call that he's having right now. Um, yeah, I think I'm able to see. It's a very early call, but with some folks in Facebook. So let's see if they can join us. That would be great. Anyway, so basically, I was expecting to have like new faces, but let's go for a second round of just introducing ourselves very briefly. Maybe that would be helpful to put us again, in online. So I'm Luis Rodriguez. I'm the base seismology of Grillo, and I'm tackling some of the OpenEEW issues such as detection, mostly, and now I've been lately more interested in machine learning, which I'm very keen to test, and I'm taking a course right now. So there's a new field for me, but I feel that this will be very interesting to test, especially in the OpenEEW project. So let's see how it goes. I don't know, guys from Daniel or John, maybe.
Sure, I'll go. Yeah, so I'm Daniel Crook. I'm a CTO for Call for Code, which is IBM's Tech for Good program in partnership with the United Nations and the Linux Foundation and a bunch of other partners. So my role is to really help projects like OpenEEW that go into the Linux Foundation succeed. Second to that is my day job as a developer advocate for IBM. So John and I work together. We help folks, our customers, the general community of developers use open source and IBM technology. Most of our cloud's based on open source, like Kubernetes, Cloud Foundry, OpenWhisk, things like that. So we're really interested in seeing how OpenEEW grows and kind of how individuals can develop on it using that technology, deploy their own instance of it, or work together with the Grio team to work into the larger consolidated network. So that's my interest, and very excited about some of the dashboard work going on, and that part of it's great, and of course running stuff on Kubernetes, so people have like a public endpoint for their MQTT instances and their detection engines that they can point to, test against, and then get into the main project. Yeah, John.
And I work very closely with Daniel. I'm one of his rowers, and I chop wood and carry water with him. So I, as an IBM developer advocate, my expertise is in IoT and edge devices. So firmware and programming edge devices and little MCUs, sort of one of my skills. But I'm also a Node-RED developer, so I create lots of different dashboards with Node-RED and MQTT, building models, collecting data from devices, and building models and displaying them in dashboards. So I'm really excited to be here too.
Thanks. So how about I don't know, Ryan, maybe?
Yeah, sure. Yeah, I'm a web developer in California. I teach at UC Riverside, or at least just got a job as an instructor at UC Riverside. So for full stack web development, a boot camp there, and then I develop. I work as a freelance developer, but I'm particularly interested in things like data visualization, and I've started a little bit of machine learning myself. I'd like to learn a lot more about it. I think it's really, really interesting stuff. For the last week or so, I started getting the very sort of bare bones together for like a web-based dashboard that hopefully will connect to the sensors. And I pushed a little bit of it to Heroku just earlier this morning. So it's in the dashboard Slack if anyone wants to take a look at it. But yeah, outside of that, I'm really excited to work on all parts of this project.
Great, thanks. So, Vaclav, right?
Yeah.
Is that correct?
Václav. Yeah. Pretty close. I'm
Okay.
used to all shapes and sounds of it. So I'm Václav, and I just finished several months ago, I finished my PhD in seismology at Oregon State University. So I'm same as Luis, having seismological background. And because I was interested in EEWs for a couple of years, I actually was searching for something to do in this area after finishing my PhD, and I contacted Griot guys, and this seemed to me like a very good opportunity to contribute. So I just started my postdoc in Prague at the Geophysical Institute, and because we worked in Nepal after the 2015 earthquake, and we had a seismic network, broadband seismic network in there, and we had several large-scale broadband experiments in different parts of the world. So I do have some experience with seismic networks in areas like Nepal, and we have a lot of contacts in Nepal from the time of our deployment, and my advisor was actually working in Nepal for 20 years. So I thought that I would test the OpenEEW network in Nepal. So we are currently planning the project and having some kind of disaster risk reduction organization in Nepal to collaborate with. And so we are now searching for money. But in the meantime, before we get some money and before we get to Nepal, because it's a question whether and when it's going to happen, I would like to contribute to development of seismological algorithms for OpenEEW. So.
Yes, all the time is a question of when. I remember that Nepal was badly hit for an earthquake a few years ago, and I remember that a group of seismologists and hazard modelers that I was working with in that moment, they went before the earthquake, and then they were working in a project related to that area, and then the earthquake hit. So everybody in the world it's faced the same. We don't know when, but it will eventually happen all over the world. Anyway, so Heriberto Sierra. So if you now it's your turn.
Yeah, thank you. I'm also an IBMer. I'm working as a remote technical support for storage, and I saw the open for inside IBM and so on. And I'm Mexican, but I'm currently living in Croatia, and we recently have a very very strong earthquake, which damaged all the downtown. And I am kind of in this culture of early earthquake warnings, because as a Mexican, I grew up with this first earthquake after 1985 earthquake, which I was 3 years old, so I remember it. Thankfully, I don't I don't remember the aftermath, but I live it, and I think it's important to bring more people into the project to help with some. Now we are in the early development, but then we will need people for maintenance, and then we will have more networks for maybe each country, or I don't know. In Croatia, I check some where are the points, and the problem is that some center points. I don't know how is how is called in English, but the problem is that sometimes they came from Austria, and sometimes they came from Bosnia. So we will have to see if we can put some sensors there also, you know. But I'm quite interested in the project. I also find the first spot where we have permission to put one sensor. So
Oh, that's
good.
great.
Yeah, with fiber channel internet, so maybe that will be also the spot for the first server or something. But we need to see if there are more more people interested in participate and how to make all the project in the level of how to raise the money to buy the hardware, and we have we have a very large community of IT in Croatia. So also that would be very interesting if we manage to bring some people to code in the project to help everybody to to collaborate.
Good, good. No,
So
the
that's
size
my
interesting. That's the reason why I can pronounce well your name, Heriberto Sierra. You're Mexican too, so that's why. So yeah, Croatia is a very particular place. I mean, that part of Europe for in terms of seismicity. So that's a challenge there. Actually, it's very different from the case of Mexico. Very different from Puerto Rico, for example. So it's a deep seismicity allocated in that area. So I don't know, maybe Backlav can help me here later on to discuss this maybe. But yeah, so we have, I don't know what you think, guys, but I was thinking go through different, I mean, based on the people that we have here, going through discuss a little bit things that we are part of, like such as devices, maybe the dashboard, and the storage, maybe detection, and I don't know what you think. Maybe to talk about the challenges that we are facing, things where we need help, or people that can, you know, be allocated to the project and help us to solve some specific problems. Um, um, and we can go. Maybe Daniel and John can help me a little bit based on the further discussions that we have, and maybe we can come up with something here.
Yeah. So just looking back at the agenda to see if there's something specific, right? So basically, I think number one, I wanted to see if there was anything of interest in the last 2 weeks that was delivered. I know there was a lot of great action on the detection, the sensor, and the dashboard side. I'm not sure, Luis, do you have any update on the latest version of the devices, or are you not in the sensor area? Just kind of an outlook on that.
Yeah, we can move that when Andy arrives. He's the one
Okay.
who I think can give more go deeper in that subject. He's
Okay.
here. Okay, look, he's
Look at
just
that.
arrived.
Okay, cool. All right. Well, yeah, there he goes. Hey, Andy.
Hello, Andy. We're talking about you right now. You're in
Andy.
mute. You're in mute. No worries.
I'm very sorry, guys. Very sorry.
No, it's no problem. We were just finished up with introductions, and we're just talking about some of the development that's happened in the last 2 weeks, kind of delta between the last town hall and this one. So like there was action going on the sensor design and update side, the dashboard stuff. Maybe Ryan can tell us a little bit more about do his demo. And then I know on the detection side, I know a GDO was working on some stuff that I think is essential importance, at least to John and I. Me on the Docker side, he on the Node-RED side, just understanding how you might stand up a test system as a new developer to the project, whether that's on your local workstation, which I think the instructions are there, but also finding a deployed node that has a public MQTT system like we have with Docker, but hosted on a cloud, and then eventually getting to a multi-node system, right? So moving beyond the one Docker node to a distributed system, a cluster of Mosquito servers, a cluster of Postgres, whatever it may be. But I'm definitely interested in kind of seeing how that's going along and diving into that more. But yeah, I would really love to hear more about the latest on design updates and kind of what a potential sensor deployment next generation would look like, and then would love to hear about the latest in the dashboard. I don't know. So Andy, if you want to talk about the latest cool stuff, the new case.
Oh yeah, I can talk about 3D printing I can take up the rest of the meeting on 3D printing, but I'm not going to. So what I'm particularly excited about, actually, I've always had trouble with this with 3D printing. It's never been very robust. But what's nice about this new case is it's all published now on GitHub, so anyone can do this. This is just PLA, but just it's a really good snap fit case and a sort of cover so people can see. It works as an alarm straight away. So this is very good. It has little flaps so you can sort of attach it. Actually, I have a new version printing right now where we have a little level on the top. Don't know if you can see this, but where you can sort of like auto level it when you place it. So anyway, that's in progress. With the sensors, there's a few bugs that we're having at the moment. So we have some guys looking at them. The main problem that we're having is the Ethernet. It feels like we did one small mistake with regards to the wiring of the Ethernet module to the microcontroller. So that's being rectified. There's a problem with the LEDs. Only one of them works, and the buzzer. So these are minor, like the sensor is still working, but only through Wi-Fi. So once that's done, I'm hoping that in the next week or so we can fix this. And then the idea then is we probably want to do a little small batch before we actually produce the amount, because we have a lot of demand for these sensors now. So we probably want to do a small batch, 5 or 10, to test it fully before we then do the bigger batch. So we're still looking at 6 weeks or 8 weeks out before we actually have some of these boards ready. But anyway, that's the update with the sensors. In parallel to that, we've been working with Arrow to develop the next version of the sensors, which will have different connectivity options. So the next version of the sensor, this is more or less the diagram that we're going to share soon with the community, has got different plugins. So out of the box, you choose if you want Wi-Fi, or you choose if you want 4G, or you choose if you want Ethernet, and they're more or less plug-in modules. We're probably going to move away from the ESP32 for this, just because it will reduce costs and give us some more options. But anyway, I feel like that's 6 months away. So we're trying to accelerate that, but it might not be happening soon. And then, of course, we have some people in the community. I know, Vaclav, you've been doing your own sensors. We have a couple of people who've actually been making their own sensors, which I think we should probably support as well. I don't know what you guys think about this, but there are people who want to do Raspberry Pi. So you can see on my wall over there, I think 3 Raspberry Pis on the wall. We have code for that in Python. So some people like that because you can do more on the compute side. The only issue there is cost. They're much more expensive. But anyway, I feel like that's the next thing for me to do, is to publish that on the site.
Yeah. Sorry.
Go ahead.
Yeah, I have one question related to that. I was just informed today that at the institute where I started my postdoc now, we would have some resources for getting some instruments, but it would have to be this year. So it would be only the Wi-Fi ones. And the Ethernet probably wouldn't be a huge deal for me, but as you say, it's probably going to be solved shortly. But I just wanted to ask whether you think that, let's say, 10, 15 Wi-Fi instruments would be ready that I could buy this year?
Well, so the short answer to that is yes. I mean, if you didn't care about the buzzer and you didn't care about the lights too much and you didn't care about Ethernet, I mean, we can order them now,
Yeah, I can still wait longer in case that these issues are solved.
Yeah, I think it's worth it.
In the future. Well, the buzzer and those things, it's not gonna be for warning anyways at this point. It's gonna be just for testing the latencies and stuff like that. So I don't particularly care about those things that much. And so yeah, it would probably be good for me. I still need to consult things and stuff, but because the money at the institute are allocated to certain years, so and that would be money available now, so it would be good for me if I could get some sensors this year. And yeah,
so that's quite exciting. Can you tell us about your project?
Yeah, sure. I said a little bit in the introduction, but I was motivated by our visit, or several visits in Nepal after the 2015 earthquake, when we had quite a large broadband seismic experiment in there. It was 45 or 50 stations that were distributed in central Nepal, pretty much in the rupture area of the big 7.8 magnitude earthquake. And we had the stations in there for about a year, measuring the aftershock seismicity, and then we were processing the data for a couple of more years. And I was always feeling a little bit like excited on one hand, but hopeless on the other, because when we are in those villages, people are always approaching us with like, how is gonna seismology help us to like, how is this project that you are doing here, spending a lot of money on, how is this gonna help us? And we had to explain them that it's not really gonna happen like that. And so I really thought that EEWs are beneficial. Like there's in seismology community, there are plenty of people who are so much for it and also like against it, because some people overshoot what EEWs can do. And so I think that we need to be kind of, about the prospective warning and stuff. We need to be careful about what we are telling to people. And in many cases, it's going to be like in Epicenter, it's never going to help you. And in many cases, it's going to give you a few seconds or so. But I think it's really important to try, especially these ways that are very cheap. It's not like observatory grade seismic instruments, $10,000 a piece, but this is something quite lightweight. So yeah, I have been trying to get some money for Nepal, and we actually got some money in the institute. So I think that in some very simple shape, we can hit the trigger on that. But I'm still hoping to get more money and be able to do a little bit more. Let's say 30, 40 instruments to be able to do some basic detection to locations and magnitude estimations and stuff like that, not only measuring latencies and stuff like that. Yep.
Okay, great. That sounds like good progress.
Yeah, slowly but surely. Hopefully moving it forward. Yeah.
Yeah. So I jumped in late in the conversation. I don't know where else we were. Did Ryan? Did you say anything about the dashboard?
Yeah. So I posted. I threw some of what I had up. The very basic part of the dashboard that I started up on Heroku, and the link is in the links in the dashboard Slack. So right now, most of my challenge has been trying to get a real-time chart to display the accelerations, and I can set it here. And so I feel like that's coming through somewhat of what I wanted to look like in the beginning, but of course we can change it to whatever we want. But it took a while to try and figure out some of the D3 programming of it. But yeah, so from here, we could add sensor table, really flesh out this part of the of this view or this part of the app. I figure, eventually we'll want, since this data sort of comes and goes, if we want, the app to be really useful, it could be a place for people to potentially look at like historical data and whatnot and pull any part of it. And sorry, the backend or the mock API I have, if you click the reset simulation, it resets it across the board for everybody. I need to have different, or at least separate the mock API so it creates different clients for different people. But the data in there is from, I think, the February 2018 earthquake in Mexico. So if you let it run, it gets larger.
Oh, it's real data.
Yeah, it's real data, and it's also delivered through the same JSON shape that the mock data or the sample data is in. So it's the front end of it, at least, is simulating as much as possible, the data coming into the front end. But the next thing from here is to try and figure out how to get the sensor to, what API or what server the sensor data is going to go through real time to deliver it to the front end, which is probably the biggest upcoming challenge. But yeah, I also need to add time scales and the scales for the actual numbers and whatnot. But Daniel was saying that he was interested in maybe joining in and contributing some to the front end. So I figure I could, push this to a place, or when it's at a place where it's kind of ready to be committed.
Yeah, it's great. I'm working on there's a parallel project we're building a new dashboard for It's based on Carbon as well. I had looked at the vanilla JavaScript just to get something up there and just played around with like the Gatsby instance of it. But getting to the React component seems to be the most common way to do it. So I'm really glad that it's based on that already. So I'd love to, number one, look at how you did it. Number two, try to kind of play around with it myself, not only for this purpose, but for that other project that's kind of monitoring similar types of data that's coming out of IoT. And then third, see how, it's something we can fold into kind of the test cluster package, as it were, that we talked about, whether that's as a Cloud Foundry app, which is, it uses the same concept as Heroku, the build packs.
Yeah.
So whether it's a static build pack or Node.js or something, just love to be able to let people stand one up themselves. And selfishly, from our point of view, it's running on the IBM cloud to kind of play around with it. But no, that's awesome. I think it's great, and I'd love to be able to contribute to it. I think Andy, kind of as the next step, we would love to figure out how to get to whether we use a branch or a fork of the dashboard repo along with Grafana to see how we can kind of help folks play around with this, improve this, add the axes, as Ryan mentioned, and plug it into another system where it's streaming real data rather than just something hard-coded.
Yeah, exactly. So I see this as a replacement for Grafana, right? I mean, this is Grafana. This is doing most of what we need Grafana for. In terms of the real data, that's a really good point, Daniel, because we've had a lot of people, especially in Node-RED, asking about real data. So that's something I haven't got my head around completely. How can we offer that to people? People who don't have a sensor, how can we offer them real data? I don't know. Like, I sort of feel like for Node-RED, it's probably not too difficult to set up a little instance of an MQTT broker that's republishing sensor data. For the dashboard, I'm not sure how we would do this unless you simulate it the way you've done it.
Yeah, I mean, somehow you'd have to get, I understand Node-RED outputs to JSON, right? So if you, any way you can get that into some sort of backend API, and once we build that portion of it, I mean, that'll allow us to do a lot of different things with sort of centralizing that, data and an API, so we can really kind of expand this web app to do, really a lot of cool stuff. But yeah, that's kind of the next big thing, is how do you take in everybody's sensor data and filter it through some centralized server.
Right. Oh, and so this, you just reminded me of something, Ryan. So we were having a discussion earlier on about offline about this very point. How we separate the user networks from the global network. I think this is something everyone should be aware of. And I'm not saying that we have a final solution here, but the idea is that I think we realized early on that we can't have everybody sending their sensor data to a centralized place because it's too much. It's just too much. And also, especially now where we're not doing any edge detection, it means to say we're getting just all this telemetry every second from every sensor, and 99.9% of it is useless. So I think what the discussion we've been having is that maybe these individual networks, like we have in the Docker, these individual networks or in Node-RED, they only serve the user and his network of sensors, but they also periodically send data to a central repository, which will include events of earthquakes and anything to do with devices, so we can plot them on a map maybe. That's my take on it, but this is an ongoing discussion, right, guys?
Yeah, and I think it's a progression too, right? So as people want to kind of play around with dummy data, just testing their device, testing a new accelerometer, testing a new board, there's definitely going to want to be that sandbox piece where they just run it completely locally, or they decide I'm going to just test out a distributed system, and then they get to their own space where maybe they want to run their own community level instance in some fashion. And then there's got to be some kind of gradation that's like, okay, this is now a tier 1 provider of information. It can be trusted. It's a network that we've seen is serving its community over some amount of time, and now we'll allow it to bring data into the global system, or at least tag it. Okay, this is the really trustworthy stuff that's proving itself a more complete system And then here's other stuff that's just, here's an experimental node that popped up at this university. It's great to see that. And here's the community if you want to join that community. Kind of a way to raise awareness of all the work going on. At the same time, balancing what's really the trustworthy data right now versus what's experimental. I think there would be great if there was kind of a proposal pulled together of what that graduation is. And that way people are more comfortable, throwing data at a system and not screwing everybody else up as well, which helps people feel more comfortable with experimentation, I think. So yeah, I'd love to see something kind of come together on that.
Yeah. The trust issue, Daniel. I had a chat with someone recently about this, and they made a suggestion that, we have trust levels, and that you earn the trust before the data becomes part of the global network. Because as this expands, we're going to get data that we know nothing about the installation, and we know nothing about the device. So, at some point, whilst there is some automation we could do to filter out noisy signals and not allow them in, I feel that, if you're a university, your trust level is already 100. Or if there are certain instances where you automatically gain trust, or people can work towards that. I think this is something we have to look at more. But I wonder if because that seems to be the big issue. How do we allow anyone to declare an earthquake?
Sorry. So ultimately, you are thinking about one global system that would just be plugging in stations that would be contributing to a global system, or would it be some larger regions, for example, that make sense from a seismological, like, one region, like a west coast of the US, or, some things where large earthquakes are going to occur in one seismic zone that would be separate networks. Because in a way, it would make maybe sense to think about it in this way too, because earthquakes are not distributed on the globe randomly, but they do concentrate in these large areas. And something where we target the earthquake early warning at something very large, magnitude 7.5 plus, there is much fewer areas over the globe where those earthquakes occur. So maybe if you kind of made regional systems that may also have some regional variations in those algorithms that they use. It's just an idea. It's not something that I would think.
We actually have had this discussion at GRIO a few times in the past, and what you said there about the sort of maybe the geological differences are interesting. But I ultimately what we did with the repository in OpenEEW and on AWS is we took away the country codes, and we now just organize them by devices. We took away, because we didn't want to create a borderless system, and regions have a problem of fencing things in. And earthquakes do overlap on borders, and I feel there's a parametric solution, which is something that we did a paper on once. There's a parametric solution where you can say it doesn't matter from what network it comes. An earthquake will only affect people within a certain radius of it. So if you pre-program these sort of parametric constraints, you can say that a magnitude 7 will only affect however many hundreds of kilometers. And it doesn't matter which region or network it originates from. It depends where is the user relative to that event. I'm scared of getting into regions, because what happens if you have two people creating in the same region, or what if you have someone where the border is? How do you define those boundaries?
Yeah, I was just thinking, for example, like what I think we are facing in Nepal, or what the problem is going to be, is that you cannot really estimate the magnitude straight away, because those P waves saturate very quickly. And in order to get to deliver a timely warning, you will have to deliver it, or like you will want to do it at a point where a P wave is like when you have 3-4 seconds of a P wave. And at that point you think, okay, this is likely to be a magnitude 6, but it may also be a magnitude 8. And in that case, in Nepal, where the magnitude 8 approximately is going to be, because where the rupture zone roughly is, where the contact of the plates are, and where the earthquake is going to happen. So I was thinking about, in that case, actually delivering the warning to everybody in that rupture zone, and maybe it doesn't need to extend that far south in India or something, as if you were just drawing circles around. So, and again, this is not something that would be very well thought through, but at the same time, not everybody just in a radius around an epicenter is at the same risk because of some kind of tectonic constraint.
But couldn't this be handled on the client device? So the app that people have, or the loudspeaker, or the IoT device, whatever it is they use to get their alerts, can calculate its distance to the event. So you don't need to create rings, if you know what I mean, or radiuses, because every user will have a different relationship to the event based on their location. Like it's automatically done within the system. I mean, I just, right here on my desk, we just had an earthquake a second ago. This is I don't know if you can see this, you know.
Yeah.
So this device worked out how far away it is from the earthquake and knows that it's not going to feel anything here, you know, and that's a very simple algorithm.
Yeah, but what I'm saying, for example, in Nepal, you know where the seismic zone is, and when there is an epicenter, there is not equal likelihood that somebody who is like within the seismic zone is going to be affected the same as somebody who is away, like the same distance but away from the seismicity zone, because the earthquake is going to have a rupture zone that is roughly underneath, you know, the Himalayan arc, because that's constrained tectonically. So we know where the boundaries or where the likely rupture zone of magnitude 8 is. But somebody who is in northern India, same distance from the epicenter, is going to be affected much less, because if that turns out to be magnitude 8, it's going to really extend like in a big portion of Nepal, but not that much into India. I don't know if I'm explaining myself right, but it's not, and I'm not arguing with you that it should be some other way. I'm just like bringing this as a point that maybe a system which would consider what the tectonics of the area is, or would be somehow like designed for one region, could introduce some kind of more nuanced way how to warn people or stuff like that. Because,
no, definitely that definitely makes sense, and because ultimately what we are doing here in Mexico, based on the algorithms, it needs to be attached to the tectonic region. It's not, as I mentioned before, it's not the same that sending alerts in Croatia than sending alerts in Puerto Rico, sending alerts to Nepal or Mexico. Everything should be allocated. I think in coming back to the matter of trust of the data, and this is something that is independent of that regionalization, let's say, because having stations that can contribute to international or pool of data will have to pass a certain quality test, and I'm pretty sure that Andy was referring to that part, to that step. So independently of, let's say, allocate different networks in different regions, or even create a huge network for a specific region, all of them, they need to have a quality test, and that will need to be allocated or to attach to a quality rank. How trustful is that data in order to contribute to a certain types of algorithms? Because you were talking, and I agree with you, like, allocate the stations around a certain region because you're expecting a certain type of earthquake. That's fine, but if we don't trust, or we don't have a certain level of trust of that data, it would be very risky to make some analysis and algorithms and then to launch the alerts to the people if we are not certain about that quality, let's say.
Absolutely. Yeah.
Well, one comment there, Luis, would be I think instead of thinking about stations and sensors, we should think about networks, because the way I think might be helpful here is, if you think about all of these individual OpenEEW networks, it's the network that needs to be accepted, not the sensor, if you know what I mean, because we don't ever see the sensor data. The sensor data lives within that network, that local user network. Might be the Nepalese network, the Puerto Rico network, and ultimately, the detection isn't done by a sensor, it's done by multiple sensors, and it's done by a sort of a server that's running the OpenEEW detection system there. So the question is, do we allow that network to send us earthquake events or not? Because if we have to go sensor by sensor, that could be too much. So we might never be seeing the individual traces from every sensor. Or maybe we will. I don't know. I haven't thought about this, but it seems to me that But yeah, if everyone is running the same version of the detection software, you know, how can we tell one apart from another in terms of trust or quality?
Maybe there is an issue here where we can open like about the quality, a quality test for each of the sensor itself, a very quick and very, you know, easily deploy quality test for each of the sensors that actually allows to the whole network to have reliability, you know, I don't know,
So
rank
we
attached
sort
to
of
it.
in the firmware, we have something similar in which, I don't know if anyone's aware here, but in the firmware of the sensors right now, it will not send any data if it's too noisy. So what it happens is when it starts up, the first thing it does is it grabs a couple of seconds of data and it says, is it over a certain threshold of acceleration noise? And if so, it just resets itself, and it keeps resetting itself until that noise level is acceptable. You know, that's a filter, but we could be doing that more periodically. We could be doing that in the cloud. I mean, in the detection Docker system, we could be doing that as well. You know, is this data okay? And we could be running other tests on it as well. That would definitely be a good thing to constantly check. And if any of those tests failed, we could then send something to the cloud, so that to the central repository, whatever that is, in terms of this is not good.
Yeah, that's something that we need to think about. But yeah, definitely it needs to be there, no? Because if somebody wants to test new algorithms and it relies on the quality of the data, that needs to be at least, you know, fulfilling certain requirements. And you get me thinking another stuff, which is the installation. It's not the same that an university go and install their own sensors, that, you know, maybe somebody else has decided to put a sensor in a place where it shouldn't be, and maybe the algorithms, you know, they are putting a station in the fifth floor of a of a building. That could happen, and then you assume that the sensor is not at that high, and then you can start running algorithms or testing things that shouldn't be like it will be wrong, let's say.
Sorry, I'm just saying
You're
there's
muted.
probably a separate discussion, because we can go on a whole tangent here. But you know, for example, maybe we don't allow new networks to come in until there is, you know, a certain quantity of sensors, so we can judge them in together. But anyway, that's definitely something we need to figure out, right?
Yes, and it can be attached. I mean, it can be at relies in a very simple query. Let's say, like, if you have, I don't know, let's say 15 stations, then you can basically say these stations are in the ground level of these certain type of buildings, are located blah 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 blah. That will give us basically a good idea of how, I mean, if it's a good quality or a medium quality station, and that will save a lot of time, let's say. But yeah, let's.
And maybe one more point to this. I think it's a really good idea to have some kind of quality control, also because you want to encourage people to deploy stations and actually acquire the sensors and monitor, but at the same time you probably don't want people to like run complete independently EEW systems and promise something to the public without that being
right,
like, you know, absolutely correct. Because you don't, I think that you should be like very careful about not discrediting the system by promising something that cannot be done, because I think you know, it is very easy to like take it too far and promise people minutes of warning before an earthquake happens, and it's just something that the system cannot deliver. And I think it's important to like, so people who deploy those sensors are aware of the limitations of the system and stuff like that. So I think, yeah.
You're absolutely right. The education component is so important as well, in terms of letting people know how the system works, because this is a life and death system. You know, people have died because of false alerts in Mexico. There's been false alerts here where people have jumped out of windows because they're so scared. People have died. You know, you can get this wrong, and one failure in one system could discredit the whole. So I think you make an excellent point there. Yeah.
True.
Okay. Anything else we want to discuss?
Sorry.
Just one thing. Yeah, so I just opened up an issue for the dashboard, by the way, to track stuff there, so we can kind of document as we go. Go ahead.
Yeah, I just want to ask. Yeah, I'm sorry. sorry.
No, similar. I've because we have so many great ideas. I too captured a number of good first issues that we don't want to lose. Right, we have this conversation, and then some really initial design thinking, and so I wrote up 3 or 4 of them. I see Andy's created a few too for some of the dashboards, the Node-RED dashboards. So I encourage everyone to, if we spend the time in the discussion on design, we should try to capture that as an issue that we can go back to and review, especially if someone new coming into the project is listening to the playback and says, wow, I want to go work on that. Where? And other than finding some conversation in the channels, we've got a GitHub issue that we can say, hey, rally around this.
Yeah, and I think the OpenEEW.com and GitHub, I think they needed to just be updated with here's how you get started with the overall project, which I think is good. It's in the main EEW repo. And then basically how you get involved in individual pieces and how you see those great first-time issues. I think we consolidate the docs.
Yeah, so I don't know if a couple of people may have noticed, but we now have a docs channel. And a former colleague of ours from IBM, Amy is Reynolds. She's not on the call with us today, but she was an editor for IBM Developer, and so she's looking for an opportunity to contribute. She lives in California, so sort of a personal interest to her now, and so she's going to help possibly with some of the documentation efforts. So if you need some guidance on how to structure your readmes and the docs, she'd be a good resource.
That's great. I had a question for you guys, actually. So I was speaking with Todd from the Linux Foundation, and he was recommending. Basically, I mentioned to him a while ago something about a long time ago about Slack, and I said to him, the problem I have with Slack. We're not going to change Slack, obviously, because we all use it. But the problem I have is that sometimes discussions are lost, especially because we're on the free plan, and sometimes these sort of threaded conversations are hard to find. And I remember telling him I really like the way, say, Particle did it with Discourse. Discourse is a really good forum system, but we don't want to have too many because we already have one, and that's enough. One is enough. But he did mention that there's this new thing, which is Github Discussions. So my question is, has anyone used Github Discussions? It seems to be in beta, and he was going to see if he could get us on it. But what I liked about it is it's more of a structured forum where you can post problems, maybe you can tie them to issues. I've never used it before. But I like that we get a lot of repeated questions in Slack. At least I do on direct messages. And I like the idea that someone coming new to the discussion doesn't have to trawl through these threads and these things, and they can just find the answers. There's a sort of knowledge base, which is not a wiki or a website, but it's a sort of discussion knowledge base.
I haven't
heard about that
yet. Sorry, John. In IBM, we have a lot of experience working on Slack. It's important that everybody try to use some kind of formatting. So then you can search on Slack. For example, you can search the topic, and then you use the property has and then link. So you will search all the entrants which that topic that has some link, for example, and the use of threads and the channels. People tends to write direct messages, which is not good because that is not visible for the other people. So it's just how to use the tool and not the tool itself, because the tool, I think it's quite good, but we need to everybody use the treats and start to put everything in the channels and try to see if there will be some kind of format we need to ask for new topics, for example.
Do you have a link to that structure or some sort of guideline for what you just mentioned there? Because I could post that to the Slack greet bot.
I I made a internal course in IBM in W3 sites, but I'm now in my personal computer, so I will post it tomorrow if it's okay. So it's it's now kind of old, the course, but everything it's all the basics are already there. So the importance of use the channels, the importance of use the treats, the importance of don't use the direct messages, and it's just learn by doing, just like everything else. So I can provide the link tomorrow, because I need to see if it's public and so on. And from this computer I cannot find it because it's outside of the IBM VPN. So
Yeah, I think that would be helpful. Yeah, and I think basically, and it's always going to be an iterative process. I think, Andy, finding out what works best for the community without going too prescriptive from the start. So just finding out what works, I think, for most folks. But yeah, no, I think it'll probably evolve too. It is interesting just to compare Linux Foundation with the Apache Software Foundation, which I prefer the Linux Foundation model, but Apache Software, they tend to be very prescriptive about this sort of thing, in that they actually don't even use, I don't think, Slack for many Apache projects, and anything that was in Slack, they required to send a digest to a mailing list. So they literally are still mailing list centric, which is not great in and of itself. But they had pulled together a bunch of tools in order to link together the activity in GitHub, link the activity in Slack together with the mailing list, which is kind of considered the place of record. Any decision didn't happen unless it happened on the mailing list. And so what they did was bridge it forward to say, okay, here's the conversation digest from Slack today. It includes some discussion of the issue, and then basically summarize it there. That's, hey, listen, this is the decision we decided to go for. So long story short, I don't have a straight answer, and it's very particular to every particular open source community I've been part of. They all do it slightly different, but maybe finding one channel, designating that, or one, whatever it is, not to overload the word channel, but whatever tool, that becomes kind of the place where the decisions are made. That's the public of record, and then everything else maybe is integrated into that. Another thing that we do for a lot of projects is we subscribe to all of the GitHub repositories from a particular channel. So for example, and I know this goes crazy with the free tier and the 1,000 messages, but if each of the channels was subscribed to the particular repo, they would get notifications by default about pull requests and commits. You can tweak it to be issues and follow-on comments as well. It's another approach that could be there too, just to keep everything in sync, as every message that happens on GitHub is also echoed back into Slack.
Great. Sounds great. Okay. Right. Well, there's nothing else for me. I don't know about you guys. I think this has been quite productive. Daniel, did we discuss earlier maybe suggesting working groups? I don't know if you've had that discussion already, but the idea that we might want to sort of look at detection. I think we talked about this as well with Racklab, the idea that you might have some people looking at a specific form of detection as opposed to the one we're currently doing, a branch of it, which we might merge in at some point. I think that's something that we need to do. So maybe we need to identify, people who want to work on that. I forgot what else we wanted to look at in terms of working groups. There was another one, wasn't there?
Oh yeah, the edge computing stuff was important.
Oh, yeah, edge computing.
The trade-offs of just being a fire hose of data from the sensors versus only sending relevant information in order to conserve some bandwidth, some power, stuff like that. But yeah, no, the idea of working groups, I think we could look at a couple of different models. The one that does it really well, obviously a much larger project, is Kubernetes. They've got special interest groups, they call them, SIGs. So they've got some structure to them. But again, there's lots of great examples out there, not just Kubernetes. But basically, what it does is it helps form a set of individual a meritocracy around individual components. So for example, if there's a bunch of folks that are, they've earned the rights to commit directly to the Node-RED repo, but we don't necessarily want to give them write access to the sensor repo. If you tie the SIG to each of the individual teams for the repos, maybe they use their own wikis to do their free-form notes or something. Maybe they have their own little breakout meetings. Those are all good models we can explore. So maybe it makes sense to propose a few of these, propose some leaders to basically own those areas, and then allow them to kind of nurture the internal set of issues and stuff within.
Great. Yeah, I really want to support what you said about edge computing, because whilst we develop these sort of new sensors with different connectivity options, they're going to be useless if we haven't figured out by the time they come what we want to be doing on the edge. And in fact, we need to define the specs of these machines, how much RAM they use, how much storage they have, and that is dependent on what processors they're going to be running. So trying to define at least the basis of what computing these are going to be doing is going to help us sooner rather than later. So yeah. Okay, I think we've hit 3 o'clock. Shall we close it up?
I think there was just one more thing, Andy. I don't know if there was anything we needed help with, or we wanted to put a call out to the community. Maybe those who are listening to this recording, even something we would really love some eyeballs on, some help with, or if maybe it's just something we just can post in Slack for now.
I mean, for I've been focused mostly on sensors recently, and for me, given the demand we've got for people to get sensors, having help with the sensors for me is a priority. But of course, that I think we need help in everywhere. So I think we already have a couple of people working. Gareth, which John introduced to the project, is going to be receiving a sensor to help us debug it, and we also have Rafael, I forgot his name, sorry. And we have some Rafael, who's also looking at these in Portugal, so he should have received this today. But yeah, that's from me anyway. Okay. Well, I think that's it then. We can keep chatting on Slack for anyone who wants to know. That's pretty good.
All right. Sounds good. Welcome, Heriberto.
Thank you. Thank you, guys.
Thank you.
Yeah.
Nice to see you.
See you guys. Okay. Bye.
Bye.
Ciao.
Ciao.